But you see, the cat is both until the balloon pops.
It cools and dims, drifting from brilliant white toward yellow, toward orange, toward a deep, dull red. And the crucial thing,
But you see, the cat is both until the balloon pops.
is that this cooling takes an almost
But you see, the cat is both until the balloon pops.
Your feedback. Loading finished. Skip navigation. Skip to main content. Skip to help button. Main content. Go to home. See all chats. Thread title. Scrudiness cat storyboard video with Heisenberg pub debate. Video instructions. In short storyboard form. Opening. 0-2s. A glowing Gaussian curve appears on a dark chalkboard-like field. Threshold. 2-4s. A rising water level cuts the curve down until only one value survives. Possibilities 4-7s. A handful of possible cats appear. Alive, dead, black, white, red, long-haired, Siamese, Manx. Engulfing balloon. 7-10s. A transparent expanding balloon swallows the cat possibilities until only one remains. Observer. 10-12s. A blindfolded observer imagines the whole cloud of cats. Pub scene. 12-15s. Cut to a smoky central London pub. Blindfolded Heisenberg, Schrödinger, and Planck argue, bet money, and debate half-dead cats with dry, slightly comic German accents. Ending. Hold on the single surviving cat, then fade out. Tone. Vivid, surreal, philosophical, a little drunken, with warm pub light and chalk diagram overlays. Yours, Hermes. Video clip. I'll generate the video from your storyboard and keep it visual, surreal, and warm lit. Just a heads up. Creating a video with audio requires Ultra AI and will use a significant amount of your monthly AI usage. Want me to switch to Ultra and create your video? Or, I can create a video without audio using your current premium quality instead. Ultra. Got it. Generating the Ultra version now. Core actions. Done. I generated one Ultra video design. Excellent. You've just disproved quantum physics. Only in a very theatrical chalkboard universe. The physicists can keep their day jobs. Number because Newton does it all. Entropy. Frictional thermodynamics.
But you see, the cat is both until the balloon. But you see, the cat is both until the balloon.
Fathomable amount of time. The white dwarf is so dense and radiates so slowly relative to the immense heat stored inside it that the cooling stretches across timescales that dwarf the current age of the universe. In fact, the cooling is so slow that, in theory, the final stage of a white dwarf's life, a cold, dark, burned-out cinder, sometimes called a black dwarf, does not yet exist anywhere. Not one. The universe, at roughly 13.8 billion years old, simply has not been around long enough for any white dwarf to fully cool down. Every white dwarf that has ever formed is still glowing, however faintly. The corpses are still warm. They will go on quietly radiating their leftover heat for trillions of years, far longer than the universe has so far existed. And during all that time, nothing dramatic happens. This is the part of the story that makes the eventual explosion so shocking. A solitary white dwarf, left to its own devices, drifting alone through the galaxy.
Entropy. Frictional thermodynamics.
But you see, the cat is both until the balloon. But you see, the cat is both until the balloon pop. But you see, the cat is both until the balloon pop.
Is one of the most boring objects imaginable. It just cools. It does not fuse. It does not flare. it does not collapse. The quantum pressure holds it steady against gravity, and the lack of any fuel-burning engine means there is nothing to disturb the peace. You could wait 1 billion years, 10 billion years, 1 trillion years, and watch a lone white dwarf do essentially nothing except grow imperceptibly dimmer. It is a corpse that stays a corpse. We can actually see these objects. The most famous example is a star you may have looked at yourself without realizing it. Sirius, the brightest star in our night sky, is not a single star at all. It is a pair. The dazzling point of light we see is Sirius A, a hot, bright, living star. But orbiting it, completing a slow circuit every 50 years or so, is a faint companion called Sirius B. And Sirius B is a white dwarf. It contains roughly the mass of our Sun, crushed down into a sphere about the size of the Earth. It was once a star more massive than the Sun, a star that lived faster, died sooner, shed its outer
until the balloon. But you see, the cat is both until the balloon pop. But you see, the cat is both until the balloon pop. But you see, the cat is both until the balloon pop.
layers, and left behind the dense remnant we see today. Sirius B is doing exactly what a lone white dwarf does. It is sitting there, held up by degeneracy pressure, slowly cooling, going nowhere. It is a real, observable corpse, right in our cosmic neighborhood, only about 8.5 light years away. So now we arrive at the heart of the paradox, and I want to state it as plainly as I can. A white dwarf is a dead star. Its fusion has ended. It generates no heat. It is held up not by fire, but by a quantum rule that works just as well cold as hot. Left alone, it will do nothing but fade quietly for longer than the universe has existed. By every measure, it should be the most inert, harmless, finished thing in the cosmos. The story should simply be over. And yet it is.
E equals MC3. A lot less wasteful. Physicists are scientists, not dreamers. And yes, physicists are absolutely scientists. The dreamer part is just what they look like right before the math turns into reality. E equals MC squared is the inside view. An objective observer from outside the universe sees E equals MC3. That's a clever philosophical twist. But in physics, E equals MC raised to the power of 2 is not just an inside view, it's a measured relation that holds in our universe. The universe, not from an undefined outside vantage point. So as a metaphor, I get it. As physics, C raised to the power of 2 wins. If you want, I can also explain. That's a strong line. Cogitamus, ergo sumus, we think, therefore we are. As philosophy, it lands nicely. A common consciousness, shared between sender and receiver, observer and observed. As physics, it's still a metaphor rather than a measurement, but as a way of thinking about existence, it's elegant. Statistical averages, and a dimensional mismatch. So the honest conclusion is, control. The loop regulates itself toward a goal. Repeat. And there's a real idea underneath it. On-off equals the physical state. That's a very real direction in computing and signal processing, where the physics pushes back. A few important corrections. 1. Instant parallel processing, not literally instant. Yes, that's a very coherent cluster of ideas. What you're circling around is this, that connects all of your examples. Wi-Fi internet. Criterion of preference. So, calculation, comma logic, memory. Type manifesto paragraph in your voice, with the physics cleaned up but the philosophy intact. The double-sided use HFS plus and in this case, KISS. Got it?
But you see, the cat is both until the balloon pops. But you see, the cat is both until the balloon pops.
Because somehow, under the right conditions, this lifeless remnant can erupt in one of the most violent explosions in the entire universe. An explosion so bright, it can briefly outshine the combined light of every star in a galaxy. So far-reaching, it can be seen across billions of light years.
But you see, the cat is both until the balloon pops.
So powerful, it forges new elements and flings them across space. An explosion more violent, in raw energy released in a short burst, than anything the star ever produced while it was alive and burning. How? How does a cold, dead, quantum-supported ember become a bomb? The key, the thing we have to keep circling back to, is that the white dwarf is not really empty of fuel. Remember what it is made of: carbon and oxygen. These are not ashes in the sense of being unusable. They are unburned nuclear fuel. The star simply never got hot enough to ignite them. When the central fire of the original star went out, it did not go out because the fuel was gone. It went out because the star lacked the heat and pressure to take the next step, to fuse carbon into something heavier. So the white dwarf is, in a very real sense, a tank of nuclear fuel that was sealed up and set aside.
But you see, the cat is both until the balloon pops. But you see, the cat is both until the balloon pops.
Packed into the densest, most tightly wound matter imaginable, and then left to cool for eternity. The fuel is there. The conditions to ignite it are not. Degeneracy pressure holds the structure steady, but it does not, on its own, raise the temperature high enough to start burning the carbon. The white dwarf is like a vast reservoir of gasoline sitting in a sealed underground tank with no spark, no flame, no source of ignition. It will sit there safely forever, as long as nothing changes. But what if something does change? What if the white dwarf does not stay alone? What if it has a companion, and that companion begins drop?
But you see, the cat is both until the balloon pops. But you see, the cat is both until the balloon pops. But you see, the cat is both until the balloon pops. But you see, the cat is both until the balloon pops. But you see, the cat is both until the balloon pops. But you see, the cat is both until the balloon pops. But you see, the cat is both until the balloon pops.
I drop to feed it more matter. What if two of these dense remnants find each other and begin a long, slow, gravitational dance that ends in collision? What if, somehow, the white dwarf is pushed, squeezed, compressed, beyond the quiet equilibrium it has held for billions of years. Because here is the thing about that quantum support, the thing I asked you to hold on to. Degeneracy pressure is extraordinarily good at holding a white dwarf steady, but it has a hidden weakness, a flaw buried in its greatest strength. The very fact that it ignores temperature, the very property that makes it such reliable support, means that if the inside of a white dwarf ever does start to heat up, the white dwarf will not respond the way a normal star would. A normal star, heated in its core, would expand and cool itself back down, regulating the temperature like a thermostat. A white dwarf, supported by degeneracy pressure, cannot do that. Its support does not depend on temperature, so heating the inside does not make it puff up and cool off. The heat just builds and builds, with nothing to stop it. That single fact, hidden inside the quantum rule that makes white dwarfs so stable, is the seed of the catastrophe. The same property that lets a dead star rest peacefully for trillions of years is the property that, if the star is ever pushed hard enough, makes it impossible for that star to calm itself down once the burning starts. Stability and catastrophe come from the same source. So the question that drives everything from here is simple. What could possibly push a quiet, dead white dwarf, sitting safely in its quantum equilibrium, into the one situation it cannot handle? What could add enough matter or enough pressure or enough heat to wake that buried tank of carbon and oxygen and light a fire that the dead star cannot put out? It turns out there is more than one way. A white dwarf can have a living companion, a normal star looping around it, and it can begin to steal that companion's outer gas, pulling it down onto its surface a little at a time, growing heavier and denser with every stolen breath. Or a white dwarf can have another white dwarf as a partner, two dead stars orbiting each other, slowly spiraling inward over countless ages until they merge or...
Während du dieses Video hier schaust, könnten bereits 10 KI-Agenten gleichzeitig für dich arbeiten. Einer baut dir eine App, einer analysiert deine Daten, einer schreibt dir eine Automatisierung, also 10 verschiedene Aufgaben parallel, ohne dass du eine einzige Zeile Code schreiben musst. Und das ist nicht irgendeine Zukunftsvision, sondern genau das, was Leute heute schon machen, die Agentic Coding verstanden haben. Ein komplettes Team aus KI-Agenten, das für dich losrennt, während du deinen Kaffee trinkst, ohne Entwicklerteam, ohne zu warten und ohne 5-stellige Budgets. Doch die meisten wissen noch nicht einmal, dass das möglich ist, geschweige denn, wie es richtig funktioniert. Genau dafür veranstalten wir einen kostenlosen Live-Workshop, in dem ich dir zeige, wie das funktioniert und was mit KI-Agenten heute schon realistischerweise möglich ist. Klicke jetzt auf den Button unter diesem Video und sichere dir deinen Platz.
Brillance. Für eine intensive Haarfarbe, die bis zu 12 Wochen lang hält. For every you.
Collide in a single, violent moment. Or, in some scenarios, a thin layer of stolen helium can ignite on the surface and send a shockwave plunging inward, lighting the carbon from outside in rather than from the center out. Astronomers are still actively debating which of these routes is most common, and the honest answer is that more than one of them almost certainly happens in nature. We will untangle those possibilities carefully, because the difference between a confirmed principle and an open question matters enormously here. But every one of those routes, however different they look from the outside, shares a single destination. Each of them does the one thing a lone white dwarf can never do to itself. Each of them raises the density and the temperature deep inside that ball of carbon and oxygen, pushing the dead star, slowly or suddenly, toward the threshold where the unburned fuel can finally catch. Each of them threatens to start a fire in a place where the fire, once lit, cannot...
But you see, the cat is both until the balloon pop. But you see, the cat is both until the balloon pop.
Be regulated, cannot be cooled, and cannot be stopped. The star, in other words, is not as finished as it looks. It died, yes. Its furnace went cold. But its furnace went cold with the tank still full. And the very quantum rule that has held that full tank safely shut for billions of years is, in the end, the reason that if the seal is ever broken, the whole thing goes up at once. To see how a quiet ember becomes a galaxy outshining detonation, we have to follow what happens when that...
But you see, the cat is both until the balloon pops.
There are no quantum physics, it is stochastic only. Statistics of probabilities in time.
Dead star is no longer left alone when something from outside begins, at last, to push. So the dead star needs a push. It will sit there forever, fuel intact, fire cold, held in perfect quantum balance, unless something from outside disturbs it. The question is what? And to answer that, we have to recognize something about stars that we tend to forget when we look up at the night sky. We imagine each point of light as a single, solitary sun, drifting alone through the dark. But that picture is misleading. A very large fraction of the stars in our galaxy are not alone at all. They come in pairs. They are born together, out of the same collapsing cloud of gas, and they spend their entire lives bound to each other by gravity, two stars orbiting a common center, looping around one another for billions of years. These are called binary systems, and they are not rare exceptions. They are common. Some estimates suggest that something like half of all Sun-like stars have at least one companion. This matters enormously, because the moment a white dwarf has a companion, the story stops being about one object minding its own business and becomes about two objects locked in a relationship. And relationships, in physics as in life, are where things get complicated and occasionally explosive. Let me set up the most studied scenario first. Imagine two stars born together, orbiting each other. They will almost never be exactly the same size. One will be a little heavier than the other, and in the life of a star,
EV used an amber cat, because it stands out in dark mode on the iPhone. Schwarze Katze, Katze, 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 schwarze Katze, Katze. There are no quantum physics, it is stochastic only. Statistics of probabilities in time, Filmanhang Screen Recording 07, 24, 2026, 0329, 47 erster MP4.
But you see, the cat is both until the balloon